Hello viewers, we are pleased to bring to you another program in Teleschool Junior Series. The subject today is set. Set theory is so fascinating that we can spend years and years studying them. However, today we'll only have a glimpse of this world. So let's start. What is a set? A set is either a group of persons having something in common. For example, group of persons playing football. They play football. Group of students playing volleyball. Group of pupils reading comic books. Group of tourists speaking French. Group of girls having dogs. They all are examples of set. Or a set can also be defined as a collection of objects which have a common property. For example, group of quadrilaterals. That is, the set consists of polygons having 4 sides. Group of triangles, collection of even numbers, collection of prime numbers. They are all examples of sets. The persons or objects included in a set are called members or elements of the set. Now we are going to illustrate to you how to represent sets. In fact, there are many ways of representing sets, and you should be able to know how to transform one representation into another. Let's consider 3 children who play football, namely John, Mike, and Robin. So here the common property is that all the 3 children play football. How to represent this in form of sets? The first method is simply to write their names and draw a fence. Usually the fence will be in the form of a circle, or you can also use pictorial representation. Such diagrams are referred to as Venn diagrams. Remember, the fence separates all children playing football from all those not playing football. So usually the fence will be a circle. And remember, these diagrams will be referred to as Venn diagrams. The second method would be to write the elements or the members within curly brackets. Here we have written the 3 children, the name of the 3 children within curly brackets. John, Mike, Robin written within curly brackets. The next method is to write the common property of the members or the objects within curly brackets. For example, we can also describe or represent the set by writing the common property, which is children playing football within curly brackets. The fourth method would be to give a name to the set, and this is very popular. We give a name to the set. For example, here we have decided to call the set by the name F. Therefore, the set which consists of children playing football will be called F. So we are going to write it as F is equal to John, Mike, Robin within curly brackets, or we can also write it as F equal to children playing football, that is the common property within curly brackets. We can also label the fence by F, or we can also label the fence by the property. Therefore, remember, this is a very common property. The next method would be to show the number of elements in the set. Instead of showing all the elements, we show just the number of elements in the set. For example, there were 3 children who play football. Instead of writing their names, we have written the cardinal number with the label. So, the number, in fact, the number of elements in a set will be called the cardinal number of the set. For example, in the set F, which consists of 3 children playing football, we are going to say the cardinal number of set F is 3. Or in short, we are going to represent the cardinal number by the letter N and write the name of the set within the brackets. So instead of saying cardinal number of set F, we'll just write N and f into brackets equal to 3. The largest set that you will be working with, the largest possible set that you will be working with is called the universal set. For example, all pupils in a class will form a universal set. The set of all triangles is an example of universal set. The set of integers from 1 to 10 is an example of universal set. We represent universal set by square or rectangle. That is, all the elements of the universal set will be written either within a square or within a rectangle. Now we are going to look at properties of sets. And to do so, we'll consider a class with 5 pupils, namely John, Mike, Robin, Tom, and Jan. So all the pupils in the class will make the universal set. So we write the universal set is the set having the pupils John, Mike, Robin, Tom, and Jan. Or we can write it within a rectangle. Now, suppose that John plays football only. Tom plays volleyball only. Mike and Robin play both football and volleyball. Jan plays neither football nor volleyball. Let's give a name to the set of children playing football. Let's call it F. Let us also call the set consisting of pupils playing volleyball as V. Or we can represent it by a circle and label F. That is, the set containing all the pupils playing football. The set V will be all the pupils playing volleyball. The first set notation that we are going to look at is the following symbol, which means is an element of. And this symbol is not an element of. For example, John plays football, therefore it is in the set F. So instead of saying John is an element of set F, we will simply write John is an element of set F using this symbol. Tom is not in the set F, so we'll say Tom is not an element of set F. So we are going to write it in short form in this way. Similarly, Robin is an element of V, of the set V, whereas Jan is not an element of set V. We look at another set called the F complement. The set F complement consists of all the elements in the universal set not found in F. For example, in the class we had 5 pupils, John, Mike, Robin, Tom, and Jan. Only 3 of them played football. That is, only John, Mike, and Robin would be in the set F. Tom and Jan are outside the fence, outside the set. Therefore, the set F complement, or simply F dash, consists of 2 pupils, Tom and Jan. Now we are going to look at 2 sets together. That is, we are going to look at the properties of 2 sets. First property we are going to look at is the intersection. Consider the set F with John, Mike, and Robin playing football, and the set V, Mike, Robin, and Tom playing volleyball. We find that Mike is common to both, and so is Robin. Therefore, we'll say that Mike and Robin are common to both set F and V. And we are going to write it in a new set. All common elements are written in a new set called F intersection V. So the set F intersection V, this is the symbol for intersection, consists of elements common to both F and V. And here we find that there are only 2 elements. They are Mike and Robin. The cardinal number, therefore, of the set F intersection V is 2, because the set F intersection V consists of 2 elements only. On the Venn diagram, we can also represent the two sets and the set F intersection V as follows. We have shaded the region representing F intersection V for you. The next new type of set that we're going to look at is obtained by taking two sets all together. And the new set produced is called the union. We have the set F and the set V. F union V, this is the symbol for union. F union V is a new set which contains all the elements in both F and V. That is, we'll take all the elements in both sets, but we'll not repeat the common elements. I'll take John, I'll take Mike and Robin. John, Mike and Robin. In the set V, I'll take Mike, Robin and Tom. But Mike and Robin already appear. We are not going to repeat them. So I'll take Tom. So F union V consists of John, Mike, Robin and Tom. And therefore, the cardinal number of the set F union V is 4, because this set contains 4 elements only. And we are going to illustrate the set F union V on a Venn diagram. The shaded region represents F union V. That is, F and V taken all together. We also have the set F union V dash. That is, F union V complement. It contains all the elements in the universal set not found in F union V. And we found that there is only one element which is outside the shaded region, who is Yan. So Yan will be the only element of F union V complement. And number of elements in F union V complement is 1. Now we are going to look at subsets. Do you know that you can make many sets from one set? If not, let's see how to do it. So, to illustrate subsets, we'll consider set F, which consists of 3 elements, John, Mike, and Robin. Due to lack of space, instead of writing John, Mike, and Robin, we are going to write J, M, and R. So the elements are J, M, and R. In order to make subsets, you take one element and write it within curly brackets. So J is a subset. Similarly, M will be a subset, R will be a subset. You can also take 2 elements at a time, J and M. You can also take J and R. And you can also take M and R. So you have JR, MR. The set JM and MJ are equal. That's why we write JM only. Or you can take all the 3 elements at once, JM and R. So up to now we have 1, 2, 3, 4, 5, 6, 7 subsets of F. We'll define a new set, the empty set. That is a set which does not contain any element. And we represent it by phi or 2 curly brackets. Now remember that the empty set is a subset of every set. So we had 7 subsets of F and the empty set which makes 8 subsets. So in order to make subsets, you take 1 element, 2 elements, 3 elements, and don't forget the empty set. The empty set is a subset of all the sets. Consider that among those who played football, that is, among John, Mike, and Robin, we come to know that Mike and Robin also play basketball. So within that group, within that set who played football, we have 2 who play basketball. So we will say that B is a subset of F. So if F consists of John, Mike, and Robin, then the set of all those playing basketball consists of Mike and Robin only. What is the set B intersection F. That is, what are those elements which are common to both B and F? Let's see. John is not common. Mike is common to both. So is Robin. Therefore, the set B intersection F consists of two elements, namely Mike and Robin. But we found that this is exactly same as the set B, which means that in this case, B intersection F is nothing but the set B itself. And we have shaded it for you. The shaded region represents B intersection F, which is nothing but the set B. What will be the set B union F? Let's see. B union F will be nothing but the set F, because you are going to take all the elements in B and F, but will not repeat the common ones. So it consists of John, Mike, and Robin, which is nothing but the set F itself. Now, up to now we have been shading the region for you. You must also know how to shade a region on a Venn diagram, and this helps you also to identify a particular region on a Venn diagram. Let's see how to shade the region representing F intersection V. F intersection V. So whenever you have to shade such a region, then we shade the two sets in two different colors. We have shaded the set F in blue and the set V in red. And intersection is the region in which both colors are present, or the cross-hatched region. This region is the region F intersection V. We have drawn it again for clarity. Similarly, if you have to shade the region F union V, then in this case we'll proceed by shading both sets with the same color. So we have shaded F in blue and V in blue itself. We want the region F union V. So F union V is the region where we have colors. All the colored region will form part of F union V. So we'll take all the regions. For clarity, we have redrawn it. So remember, for intersection, we'll draw. You are going to use two different colors and take the region which is common. That is the region where both colors are present, or the cross-hatch region. Whereas for union, you're going to shade in one color only and take all the regions. It's high time now that we take an example. So, in this question, you are told the universal set is all the integers from 2 to 9. There is a set A, okay, which consists of odd numbers. Set B consists of prime numbers. So note that here the elements have not been given to you. It's the property that has been written within the curly brackets. And you are asked to complete the Venn diagram and to state how many elements are not in A union B. Now, the first thing to do is to change this representation. That is, to write the elements within the set A. So, A consists of odd numbers taken from the universal set. Therefore, we are going to take 3, 5, 7, and 9. Similarly, we are going to change this representation of the set in the following. That is, B consists of prime numbers taken from the universal set. So 2, 3, 5, and 7. The next step is to write down the elements of the set A intersection B. That is, the elements common to both A and B. We find that 3 is common, 5 is common, 7 is common. So we can start by filling the region representing A intersection B. 3, 5, and 7. What remains in set A is 9 only. What remains in set B is 2 only. Now, don't forget that there is a set which is A union B dash, that is outside A union B. So, We have taken 2, we have taken 3, we haven't taken 4, so 4 will go outside. Similarly, we have taken 5, 6, oh, there's no 6, so we write the 6 outside A union B. 7, yes, 8 we haven't taken, we have taken 9. So there are 3 elements which are not in A union B. 8, 6 and 4 are those elements which do not form part of A union B. Therefore, number of elements not in A union B is 3. We'll take another example, and a bit difficult one. So let's see how to solve this problem. There are 255 tourists staying in a hotel. 150 of them speak French, 130 speak English, but 23 of them speak neither of the 2 languages. Remember, 150 of them speak French. In the question, the word only has not been used, which means that out of the 150, you may have some of them who speak English as well. So the question is as follows. How many speak French only? How many speak both French and English? How many do not speak French? So the first step is to define the sets. So the first set that we are going to define is, of course, the universal set. The universal set will consist of all the tourists staying in the hotel. That is, the 255 tourists. Let us give a name to the set of tourists speaking French. Let's call it F. So F is the set consisting of tourists speaking French only. E is the name given to the set of tourists speaking English only. And now we have written the information in set using set notation. Remember, it is very important that the figures given in the question be written using set notation. So the cardinal number of the universal set is 255. The cardinal number of set F is 150. The cardinal number of the set E is 130. So we are going to show it using Venn diagram. Number of elements in set F is 150. Number of elements in set E is 130. The next step, as we did in the previous example, would be to find the elements which be common to both F and E. Unfortunately, we cannot do so here because we don't know the elements. We just know that there are 150 elements in the set F and 130 in set E. We don't know the common elements. How to proceed? So here we are going to find the number of elements in F union E. That is, the number of tourists in set F and E all together. Now, of course, the first mistake not to do is the following. Number of elements in set F union E is not 150 plus 130. You know why? Because in doing so, we are taking the elements common to both F and E twice. That's why you have obtained 280. There are only 255 tourists in the hotel, and now you have obtained 280. So you never do this mistake. So how we are going to find the number of elements in set F and E altogether? So we take the cardinal number of the universal set and subtract the number of tourists who do not speak English or French. So 23. We said that there are 23 tourists who neither speak English nor French. Therefore, 255 minus 23 is 232. That is, there are 232 tourists altogether who speak French and English. That is, who speak either French or English or both. Now, number of tourists who speak both French and English is obtained in the following way. The cardinal number of the set F, that is number of tourists speaking French plus number of tourists speaking English, minus 232, which is 48. Therefore, there are 48 tourists who speak both French and English. Therefore, the number speaking French only would be 150 minus 48, and number speaking English only would be 130 minus 48. We have written this for you. Number speaking French only is 150 minus 48. Number speaking English only, 130 minus 48. And we have illustrated all the data in the following Venn diagram. Therefore, number who do not speak French, that is, all those outside the set representing French, is obtained by 255 minus 102 plus 48. That is 255 minus 150, which is 105. We have now reached the end of today's program. We have seen different ways of representing a set, the set notations, the properties of a set, subsets, and finally how to solve problems involving sets. Thank you for watching us. Should you have any question or suggestion, we invite you to write to the Mauritius College of the Air on the following address: Telemail, Teleschool Junior, Mauritius College of the Air, Reggie, phone 403-8200, or you can as well visit our website on www.mcawebcast.org. We would like to thank the production team of the MCA and of course you viewers for your kind attention. Until next time, it's goodbye from us.